Test all over the place. No class Thursday. I am gone. I will give you a video. It is up to you whether you want to watch the video. I mean, it's going to go over the lecture notes, which are impeccably written, if dated, right? But I will do that. I'll give you a video, maybe tomorrow, maybe Friday. I'm not sure. Maybe Thursday. We'll see. I'm only going to miss 2 classes this semester, so this is one of them. So there you have it. Okay, and where are we? 360 labs. Okay, so you got a lab due this weekend, which you can start right now. After today's class, you can finish. But you can start it. Binary coding, that's a fun lab. That one's open already, so you can have fun with it. Okay, so what we're doing today, I'm going to continue going through the libfdr library, and just so you can see pictures. I mean, again, I went through the doubly linked list thing a little bit fast, but also giving the understanding that hopefully you all have written doubly linked lists in your life. You know, if you took me for CS202, you did. Hence why I went through quickly. All right, so here's our struct. Again, it's got a forward link, backward link pointed to itself, and a val, which is this J-val, which is this union yucky thing that we do because we don't have a standard template library. Okay. So, yeah, note to self. I will. I'll delete it. There we go. Okay, so when you declare it, it's just a pointer, right? Star pointer. When you say new D-list, it's going to call malloc, and you get an empty list, and this is what an empty list looks like. Okay, forward link's pointed to itself, backward link's pointed to itself. We don't know what's in the val field. You probably shouldn't use it. You could, because I don't keep anything there, but you could. What could I keep there? You know, if I had to do it over again, I'd keep the size there. But then it's a problem, because when you delete a node, you don't have a pointer to the struct, so that probably wouldn't work. Okay, now if I call DLL append with X, and then the new JVal I, so that says return me a JVal, it's just 8 bytes, and then when I use the .I field, it's going to be 5. And so that goes ahead and creates another node, links it in, right? So forward link here, it's circular, so the forward link will be here. Again, backward link, backward link. The val field is just 8 bytes, and if you use .I, it'll get you 5. If you use anything else, you get what you deserve, because you shouldn't be using anything else. You have to be consistent in how you use your JVals. Okay. There we go. And one more. I like these notes to myself. All right, and then finally, and you can do this because you can use it any way you want. Right? I can say DLL append, new JVal S, give it a string, Fred, and what's going to happen? Again, it's going to hook it in because it's append. So append will put it at the end of the list, which means it puts it right here. And again, blank, blank, now we can chase the forward pointers, blank, chase the backward pointers, the val field. This one now you'd have to interpret with that S, and it would be a pointer, be a char star, which is going to point to these bytes, these 5 bytes, right? Fred and a new one, or sorry, and a null character. Okay, and now where were we? I know we had written some code. What had we done? Oh, we had done tail. Okay, so we were getting close to being done with this lecture. We might come back to it. Okay, so here was the code that we wrote. Was it hasty or was it expansive? Do you even remember? It was 5 days ago. Yeah? Okay. All right, so standard libfdr code. Sure, we'll go over it. Grab new input struct, which means I'm going to be able to call getLine, and it'll read from standard input. I create my list. Okay. I call getLine. Again, getLine fills in the input struct. It doesn't do any memory allocation. And so then what I'm going to do is I'm going to take the line that I read and put it at the end of this list with DLL append, and I got to call strdo to do that because getLine overwrites that input struct every time. Okay, so I call strdo. Strdo calls malloc. Counting the number of elements whenever it's greater than 10. I'm doing tail. I just want to keep the last 10. I go ahead and delete the first node on the list. And this is, again, this is unlike erase from the standard template library. Erase, you actually have to give it the data structure, right? If I want to erase, yeah, because it's a method of the data structure. So if I want to erase a node on a list in the standard template library, I have to call the method erase on that list. Fundamentally different from here. Here, you'll note, I don't have D in here, I just have the node. Right? It's just the node, and it's going to unhook itself and call free. It doesn't know what's in its JVal. So if I've mallocked it and I do this, then I've got a memory leak unless I free. So that's why I free up here. Std mallocked, I got a free because I have a memory leak. And then I traverse it and it prints it out, which is exciting. Okay, any questions on linked lists? You're going to have fun with them. Yes, Daniel?
So traversing one of these lists, do you always need like a temporary one, right? Because this always points to the sentinel. Would you lose the sentinel if you tried to like increment it or something?
Probably. I mean, again, this is a macro to a for loop, right? And this for loop is nothing too exciting. Right, here's my macro. And now I'm going to say don't do this at home, right? You shouldn't put these macros into your code. They're dangerous, they mess things up, and they make your code unreadable. But in this circumstance, they're actually beautiful. So, right, and so if you gave it the wrong stuff, right, so it's temporary variable sentinel node, right? If you give it the wrong stuff, you get what you deserve. But it's just doing this thing, right? It's just going to chase the flanks, and it's going to stop when it hits the sentinel node. All right. Okay, the last thing we have, and I probably will come back to the D list. I may or may not. Sorry. I want to make sure I'm consistent with my notes. Okay. The last thing I have is called JRB, and this implements red-black trees, which you don't have to care about. It's like an AVL tree. It's a balanced binary tree struct. Why red-black trees? Because I read a paper about it when I was implementing this. No reason other than that. Okay, and you can see it's old. Like me. See? I was an associate professor when I wrote this. When I wrote this, I was an assistant professor when I did this version. And we were in Claxton. Computer science used to be in Claxton. We used to be part of the university. Now we're not. Okay. In the comments, this is a good comment. There's a lot of junk in your red-black tree struct. You don't have to care about any of it, and you shouldn't care about any of it. In fact, with your red-black tree, you're going to treat it just like the linked list code. Okay? So you are getting a pointer to a sentinel node. That sentinel node has flank pointers. Every node has flank pointers you can traverse. Every node has blink pointers you can traverse in the reverse direction. The only difference between a red-black tree is there's no append or insert. Well, there's no append. Instead, there's only insert. And when you insert, you have to insert a data type that you can compare with, and then the tree itself will be sorted. So it's like a map. It's like a multi-map, actually. Okay? So your main node has a flank, has a blink. It has a val, just like the D-list code. It has a val, but it also has a key. Okay? What on earth is k.key? That is stale. There we go. You'll only use key and val. Now you'll note, key and val are both JVals. Okay, so you know from the D-list, the JVal is fine. With the key, it's a little bit different, right? And again, this is worse than the standard template library. Standard template library is nice, right? Because you define your multi-map with two types, and one of them needs to be comparable, or if it doesn't, you have to give it a comparison function, right? And everything's nice and seamless. With JRB, basically what I do is I give you four sets of insertion and find routines. Okay, so let's take a look. Here they are. Okay. So I got insert stir, insert int, insert double, and insert j. All right. So if your keys are strings, you'll do this. Now you'll note you're giving it a char star. It's going to turn it into a J-val. Once you store this in your tree, it's going to be a J-val whose .s is the char star. When you call insert, you don't have to use a J-val. You're going to insert a string. So this allows you to insert strings, ints, doubles, and then general. And with general, you give it a comparison function that compares two J-vals. So you're going to give it a J-val as a key, and then you're going to write your own comparison function that will do that. Okay? You can't mix and match. If you mix and match, you get what you deserve, right? So you can't call insert stir and then call insert int and pretend that anything's going to work. It's not. Right? And again, the standard template library gets around that by the fact that the type is built into your definition, so that level of checking is done for you, whereas with the red-black trees here, it's not. Okay, so those are your insertion routines. Here are your find routines, where now instead of returning you an iterator, which I hate anyway, now it just returns you a pointer to the node. Okay? If you can't find it, it returns null. Easy enough. Okay? Long time, as God intended. Okay? And then sometimes you use this, most of the time you don't. Okay? This is basically your upper bound or lower bound in the standard template library. So this is going to find, this will find the smallest node greater than or equal to what you're asking for, and then it'll also set this value 0, 1 to say whether or not it found it. Okay. Duplicates. What about duplicates, Dr. Blank? Duplicates are treated like multi-maps. So you can store duplicate values in your tree. There's no guarantee on where it's going to be stored relative to other things that it's duplicate with. And same with find. When I say, if I have 6 things in my tree whose value are 7, and I say find 7, I'm getting one of them. I don't know if it's the first, I don't know if it's the last, I'm just getting one. That's the same as the multi-map. Unless they've changed it. Have they changed it?
Repeat that.
When I call find on a multi-map, am I guaranteed to get the lowest element, or do I just get an element?
I think you get a range.
But you just get, if they're duplicates, you don't.
Yeah, I don't. There's like a find, but then there's also a find range.
Right.
So I'd assume the find just returns the lowest in the range.
Ooh. Okay. Who knows? They probably changed it. That's why I asked. I figure they've changed it 5 times. You have to keep on top of those things. All right. Deletes it. Free deletes the entire tree, including the Sentinel node. When you want to create one, you call make. One of the things about life that I'm inconsistent with, and I apologize for it, as I do every year, it's make GRB and it's new D-list. I'm sorry. It's also free tree, and I think it's delete list. Sorry, I've messed up, but I'm not changing it. This stuff's too old. All the rest, don't worry about. They're not there. Okay, so let's write some code to illustrate this. Now we're temp today. There we go. All right, here you go. We'll just write it from scratch. All right, so include standard IO.h, include standard lib.h. Do I want to include unistud and string and everything else in the world? Let's do string because I might be using it. All right, and then I'm going to include JRB. JRB.h, oh, and I'll include fields.h. Okay. Let's sort standard in. Let's sort standard in as strings. Right, so do the exact same as the Unix sort function. Okay, so what do? We'll have an input struct. We'll have a tree, JRBT, temp. We'll say new input struct, null. And then we will say t equals make JRB. Now we'll read get line is greater than or equal to 0. Then we'll go ahead and insert into the tree. So JRB insert stir T. I'm going to do the key, which is going to be text 1. And I'll just do nothing here. I'll do new jval I0. Okay. Should I be stir looping this? The answer is yes. I should be stir looping this. Why? Well, otherwise it's the same pointer getting inserted every time in my tree. I'm gonna mess up my tree. Right? I mean, if you change the pointers in the tree, you get what you deserve. And unfortunately, that is kind of a C philosophy. So I want to do stir dupe. So text 1. And again, all right, so now when I'm done, I can traverse it. So now I'll do JRB traverse. It has the same macro as the dlist. In fact, you can use the dlist macro if you want. It's the same macro. So I'll traverse temp T, and then I'm going to printf %s. The new line's already there. And that's going to be temp key dot s. So remember, the key is a jval. Even though I just inserted a string, JRB insert stir takes that string and stores it in the jval. Okay. And again, the jval is just the jval is just 8 bytes. Right? It's just a pointer. That's it. On it today. All right. How many columns do you use? You do whatever Visual Studio gives you, right? And you don't even care. 80? I like it. 22 rows too? That's the best. I do 100 now. Kind of offends me. Tabs, spaces? Tabs. Anyone spaces?
Spaces.
There we go. Good. Spaces. Clearly. Visual Studio, what's that? It's a crutch. That's what it is. It's fine. I should learn how to use it someday. Where is this code? Oh, I just created it. Okay, now I've got this. You can steal my make file if you want. I've got in my make file that if I just say if I say MK and an executable, it actually runs. It'll run a make file on this, right? Which, as you notice, has libfdr in it and has the proper include in it. Right, that's all it is. So that's in my home directory. You can steal it. It's got a bunch of other stuff in it. It's not great. All right, so let's run it. Let's get some input. So here, random names 100, junk.text. All right, there we go. A bunch of random names. We can sort them. So junk, whatever that was, junk.text into, let's call it out.text. Okay, looks like it's sorted, which is nice. Okay, how can we test that it's actually correct? Well, here, let's call sort junk.text into out2.text. All right, now how do we make sure they're the same? Diff, how else could we do it? What's that? Vim, oh, that's a Vim diff.
It's like key comparison or SS, what's it? Sorry, I forget.
You're close. Here, we'll do the diff, right? Diff, junk.text, oh, no, I'm sorry, junk, out.text, out2.text, okay? There, that's one that tells me that they're the same, right? Open SSL, MD5, out.text, out2.text, right? If your MD5 hashes are the same, you can be pretty much rest assured that your data is the same. I'd even bet a kid on this. That's how much faith I have in an MD5 hash, right? Even my favorite, right? Even Princess, I'd bet her. So even the lesser ones. I'm just joking. I love all my kids equally, unless you ask Princess, and then she'll say she's my favorite. Okay. All right. Now. What else can we do? We could sort the lines as integers. Okay, so we could do the sort dash n, which would sort the lines as integers. So how could we do that? We could do that very easily by saying a to I is arrow text 1, and then new jval s, that. All right, so, and then we'll call insert int instead of insert stir. Okay? So, now what does a to I do when it doesn't have a number? It's 0. So it's actually going to work just fine. All right, so we'll sort these. So we're going to sort them. All right, so we're going to sort them as integers. This code's going to segfault right now. Okay? Why would it segfault? Right there. That's why it would segfault. It's because I'm inserting integers, but if I try to print out the keys as strings, it's going to take whatever's in that jval and treat it like a pointer and try to go there and print it out. So I should get a segfault, and I won't get a compilation error here because this is old C code. I actually don't like this for class purposes, though. Why? Because I don't like having the optimizer on. So let's just do that. Okay. How did I get this wrong? Oh, duplicate main. Did I put junk.c in there twice? Oh, I did. Okay. All right, so if I run this now, I'm guessing I'm going to get a segfault. Oh, great. What did I do? What happened? What happened? Look at the line. What did I do?
You didn't give it any input?
Right. Instead, I said redirect standard output to the file I wanted as my input file. So that means it read from standard input, which is why it didn't do anything, except now it clobbered junk.txt, which is now an empty file. Right. Whoops. So let me create it again. There we go. And then let me write this correctly. This stuff will happen to you. You can just, so it's kind of good to know what's happening. Git, man. Git is your friend. Git is always your friend. Commit a lot. Right? You don't even have to push. Just commit. Right? Because you can get it back from the commit. Pushing can help too. Am I speaking Greek to you all? Do you all not use Git? You need to learn Git. You need to learn Git. I'm just telling you, it's one of the, it'll save your ass so many times. Better than Time Machine, better than all that stuff. And all the companies use it, so it's a good thing to know. How do you learn it? I don't know. Ask someone who knows. That's how I learned it. What am I doing? I'm doing that. Segfault. Oh, were you kidding me? It's awful. It's awful. It is really awful, right? Do we know when they changed the standard so it did this?
I've never seen that. I just thought it would crash.
Yeah. Oh my God. Who writes code? Who does that to the world? I mean, do they realize that that's like an act of terrorism? Do you all know why I'm pissed? Because it should get a segfault. A segfault is the proper answer here that says you've got a memory bug. This says, hey, it's null. Now maybe I'll count on it being null, right? Call sprintf, check for null. Now I got code that's going to break on half the machines that it runs on. It's just a travesty. I cannot believe that that's not a segfault. If I give it 0? Oh, it is getting 0. Oh, that's okay. So it's not getting garbage pointers. At least it is getting 0. Why is it getting 0, Dr. Plank? Because I'm calling a to I, and none of those started with numbers. So they're all 0. So every one of those pointers is 0. So I should be getting a segfault. Again, like God intended. But no, someone decided to play God and not do that. Ooh, let's give it some numeric input and see if we actually do get our segfault. Okay? So here. All right. Here, we'll do cat-n, and now randomize. There we go. All right. So now we got a bunch of random numbers in there, and when I run this, I'm hoping I get a segfault. Yay. Okay. So now let's change it so we don't get the seg fault. Here, we're going to print out not the key, we're going to print out the val, because that has the line. Here we go. All right, now that's nice and sorted. Okay. Let us sort strings, but we want to sort strings in such a way that we ignore case. Okay? So if we're going to sort strings and ignore case, now what we'll need to do is, we can do this in a variety of ways. Okay? I'll show you two. One way, which is what I would do, is I'm going to make a copy of the string. I'm going to turn all the uppercase letters into lowercase, and then I'm going to use that as my key. And the original string is the val. All right, so that's how you will ignore case. So if you do that, what can we do? We can say char for the key. We can say key equals stirdup is text1. And then for I equals 0, I is less than no. For I is 0, k of I does not equal the null character. I plus plus. If, am I going to use if is upper and 2 lower? No. Okay, I greater than or equal to A and k I less than or equal to z. Oh, come on, y'all aren't finding my bugs. Are you just seeing it and letting me have a bug? Yes, sir. Oh, you're right. Thank you. I had more bugs than I thought. Thank you, Team Plank. Even you're correct. There we go. All right, there we go. Then k plus equals a minus a. There we go. All right, you happy, you needy children? I'm happy. Okay. Oh, stir. Okay. I stir duped it twice. Fine, just storing 2 different strings. This for C++, they'd be making 2 copies as well. Okay, so here. There. Yeah, thanks. Sorry, you're right. I got to declare I. Tell me before these things happen. All right. What did that do? We don't know because I don't have anything. So here, let us look at our input. Oh, that's interesting. I'm like, hold it, it did it numerically. But it's also alphabetically, right? Because I have the spaces in there, right? If I didn't have the spaces in there, it would have sorted differently, right? So yeah, I took out the space and now 7 is the bottom. Because it actually is doing it alphabetically. So let's get ourselves some input there where we can actually test what we want. So here, Brooklyn. There we go. All right. So that, how should this go? It should be this one's first, that one's next, and that one's last. All right. Good. Okay, I'm happy. Now the second way you could do this is you could write your own comparison function. Okay. Now to do that, what you have to do is you have to have a function that takes 2 jvals and returns an integer. Okay, and it's going to work like strcomp. So if the first one is less than the second one, you return -1. If they're equal, you return 0. If it's greater, you return +1. So here we'll call it comp. Takes 2 jvals, jval v1, jval v2. Okay, and then what am I going to do? This is kind of a what could I do? I don't want to do the same thing I did down here because I would trash the strings. right? So now here, let's also stop. So what I'm going to do is I'm going to now change all of this, and I'm going to call JRB insert gen. Okay. The key is going to be the string, new JVal, but I got to turn it into a JVal now because the comparison function takes JVals. Okay, stirdup is arrow text 1, new JVal I 0 because I don't care, and here I'm going to print the key. And I've got to pass it the comparison function. Okay, and now I got to write the comparison function. So again, this comparison function is a pain to write. Right. But I'll do it. Here you go. Int I. For I equals 0, v1.si does not equal the null character I++. Okay. Let's get to the end of the for loop. So in the middle of the for loop, I'm going to compare the characters. If I hit the end of this for loop, then I've run out of v1. So either that means they're equal, or it means there's more to v2, and on v1 should be less, but they're equal so far. So I can say if v2 dot si equals that, return 0, otherwise return -1. All right, now I'm up in my for loop. What's the first thing I got to do? Y'all are lost.
Make sure V2 is not at its end.
Excellent. You're not lost. Fantastic. Thank you. Got to check, see the V2 isn't at the end. So if v2.si it does equal the null character, then v2 is smaller. So let's return 1. v2 is smaller. Return 1. Yes, that's right, because v1 is bigger. Lastly, now let's just compare the characters. Well, we got to convert. So here, we'll just do it. C1 equals v2 v1 dot si. If C1 is greater than or equal to A and C1 is less than or equal to Z, then C1 plus equals A minus A. Convert it to lowercase. Okay, let's do the same thing with C2. You always got to pause before that one, okay? Do you all understand what I'm doing in Vim? No, Dr. Plank, I use VS Code. This says break out into an ed command from the current line to the next line. Substitute, +1. Ooh, I did that wrong. I was talking too much. S, substitute for every one a 2. And the G says do it everywhere in the line. There you go. Should I do int or char? Char is technically right. Is there any reason why I might use int rather than char? Oh, that's a good answer if I was doing Unicode. I'm not, but if I were doing Unicode, most definitely. Right, different string representations. I was actually thinking, this is an architectural thing. What's going on in the machine, right? What is it doing? It's going to be taking, right, so first it's going to grab this byte, okay? It's going to grab this byte, put it into this either byte or int. Same thing here. Now it's going to do a comparison, maybe an addition. If these are bytes, like what does the computer itself do? Does it work on bytes or does it work on ints? Most of them work on ints. So if I do this with bytes, oftentimes there's actually extra assembly code in there that's stripping out because it has to do it as ints anyway. Might not matter. The compiler might be so smart that none of this matters, but it's just something to keep in the back of your head. Right? Would I test you on that? No. I do. Thank you, Team Plank.
You also need to close your while loop in the main function.
Ooh, Thank you. All right, look at you all.
Do you need to include JVal?
I don't, because the fields library does include it. That's a good question. Okay. I need to compare these guys too, don't I? Right? So if C1 is less than C2, then return -1. This code always feels so inelegant. If it's greater than that, then return 1. If they're equal, well, let's got to keep going. Okay? So there's my comparison function. That's a yucky comparison function. I'm sorry?
Do you have to pass in JVals into the comp function?
I do, but that gets done here, right? I'm calling insert gen, so it's going to be working on this key and whatever key is in the node of the red black tree that it's doing its comparison on. Okay, so that's where that's happening. And again, this works. You can do the exact same thing here in C++, right? The standard template library allows you to pass a comparison function to your maps and your multi-maps. Okay, so when we run this, it should run the same way. Yay, I'm happy. All right, which one was easier? Well, the first one was easier, wasn't it? No doubt the first one was easier. But that's how these things work. All right, let's clicker. Do you think I'm going to ask you like a nice big O question, or I'm going to ask you like a yucky pointer question? Oh, thank you.